to do analytics, how an existing system work without Hadoop, right? Why we need Hadoop? So we have seen yesterday that, and let me open that a diagram which I have drawn yesterday. Okay, so yesterday we have seen how the traditional system works. This is how the existing system works, where we are getting the data from the different sources, and we are taking them through some ETL process, and we're putting the data into some storage where it will in the form of table format. So because we are keeping the table format, because it is a if it is a structured data, it's easy to access. Okay, so that's why we are keeping into one storage where it will be in the form of tables that we'll call as a data warehouse system or database system. Then we will be having one processing system. Okay, this is how we are processing an existing system. So it looks good and easy, so and simple as well. Then why we need to move to Hadoop? Anyway, a beautiful design is there, then why we need to go for Hadoop, and what is the reason behind it? So to answer that, what we have done, we have loaded a huge amount of the data in the existing system, and we try to look at whether it is performing better or not. So what we have seen, these are the limitations we have seen when the data is increased. Okay, so this design was designed of so many years before. That time the data was very less, so this design was well and good, it was working good in those days. But if you take a current system and current trend, I can say last few years, the data is getting more, and everyone wants to process each and every single point of data. I can say, even if we are, everyone has a mobile, right? Everyone, the mobile also start emitting some data, and these mobile companies want to make each and every single data into a business. Then what they're doing, all their your CDRs, everything they're processing, and they're trying to improve their service as well as they're trying to improve their business, right? So in these situations, an existing system is not well fit. It doesn't mean that it will not work at all. It will work. It doesn't mean that we cannot use RDBMS at all in current days. We can use it, and based on the what kind of scenarios we are moving, right? So I want to I'm moving to show the huge amount of the data where I want to process, but in this case, this is not well fit. Where I have a big data. What is a big data? Big data is a huge amount of the data with different characteristics, right? That data we cannot process an existing system. Why? Because the data format is different. The data the data in size is huge, which is not able to, which is failing into these systems by due to some limitations, right? So that kind of data we cannot process in an existing system. So that's why we are moving to Hadoop. This is the big data. So big data is a huge amount of the data, and which cannot be able to process an existing system. That data is a big data. And we have a like a structured data, semi-structured data, unstructured data, and we have some characteristics of the each and every data. Okay, this big data has some special characteristics compared to other data. Then we started discussing Hadoop. Okay, so now I would like to continue from what is Hadoop. I would like to continue from what is Hadoop, why Hadoop. Okay. Okay, so Hadoop. So before getting into Hadoop, we need to understand what is a file system. So let me introduce Hadoop first. Hadoop. Hadoop is a framework, guys. The Hadoop is a Java-based open source framework, nothing else. It is just a Java-based open source framework, which is from Apache. But actually, the origin is from Yahoo. We will talk about the history. I will show you the history. Right, so this framework is an open source framework which is Java based. It is giving you two components. One component is HDFS. One component is HDFS. Other component is MapReduce. This component says that I will let you know how to store the huge amount of the data. This component is telling us, or this component is giving a flexibility how we want to store the huge amount of the data. This is for storage. and this is for processing. Whatever the data, the huge data you have loaded into this HDFS, I can process. So if you want to store a data, huge data in efficient manner, we will go with the HDFS. If you want to process the huge data in efficient manner, if you want to if you want to process the huge data in the efficient manner, we will go with the map and reduce. So nowadays there are some other alternatives for this. We will talk about the alternatives also. Okay, so now let's look at what is the HDFS and what is the MapReduce. Okay, so HDFS stands for, and the full form of the HDFS is Hadoop distributed. It is a file system, and this is map and reduce. You map and reduce. Okay, so what to map and what to reduce, we will talk about that later. Okay, first try to understand HDFS. Okay, so here HDFS telling that it is not a database, guys. So we need to understand one thing here. It is not a database. It is clearly saying that I am a file system. I am a file system. So it means to store huge amount of the data in Hadoop, we are not using any database. It doesn't mean that Hadoop will not support the database. It will support the database. I will show that in going forward in Hadoop ecosystems, what type of databases and data warehouse systems it will support, we will see. But the plain Hadoop, which is HDFS and MapReduce, HDFS is a file system. HDFS is file system, as similar as your normal file system, so I would like to take you guys through each and every word in this. I would like to take you guys through each and every word in this. Okay, that is what is a file system. First we need to understand what is the file system. Okay, so can anyone tell me what is the file system? What is the file system?
Is used to organize data.
Which used to organize the storage, what you are storing, what is your naming convention you are giving for the folder, and inside the folder subfolders, inside the subfolder files, inside the folder files. So it is organizing the storage. The file system means who organize the storage, whatever the data I was storing, right? The data you are storing into hard disk. Whatever the data I was storing into hard disk, where you are storing, what is the address of it, and how you are storing, what is the hierarchy. Like sometimes we will be storing C colon slash, and inside the C colon we'll be having so many directories. Directory 1, directory 2, directory 3, directory 4, and each directory 1, what are the files are there, what are the directories are there, in directory 2 what are. So this structure, this tree structure will be maintained by your file system. Okay, so this file system, who uses this file system? This file system uses by our operating system, correct? So the file system is who manages your storage, or it manages the files and directories what you are storing into HDF in our hard disk, right? So already we have a file system. Then what is the distributed file system? So let's try to understand a little more about the file system. So this is a file system. This is file system. Normally we'll call local file system LFS. Why we'll call is a local file system? Because it is local to your operating system. Why it is local to operating system? Because whatever the data you want to write here, you don't be having any control. Your operating system only will be controlling it. How to load the data into this, how to read the data into this. A simple example I want to tell you here. Let's say I have something called spark.pdf, spark dot learning spark or something, whatever the file you want. So spark.pdf or spark.txt or spark.movie or song file, whatever the file is there, the file size is 1 GB. Okay, the file size is 1 GB. So as soon as it was loading into C drive or D drive, what will happen, the data will be, the data will store in HDF, the data will store in the hard disk in the form of blocks. Guys, block is nothing but a small chunk of data, nothing else. Block is nothing but a small chunk of data. So any file system except a few file systems, the few file system, they work as a objects. Their storages are like objects, and most of the file system, the storage is in the form of blocks, in the form of blocks. Okay, so the block size in normal file system is 4 KB. Now here, whatever the data you are loading into your normal your C drive or D drive or whatever the file system you have, what it will happen, first it will break into small pieces. It will break into small pieces, and the pieces will be loaded into hard disk. So piece 1, piece 2, the piece 3, they will be having a sequence, okay, and so on. The pieces will be loaded into this. So each piece is 4 KB, which is a collection of pieces. Hard disk will load into collection of pieces. Now it is for writing. While reading also, what will happen, your operating system tells that you read piece by piece from here. While reading also, it means every time whenever it is reading the data, it is reading 4 KB. For each time, each request, it will go and read 4 KB of data. To read 1 GB data, how many times I have to read a block? I have to read a block. Say there are so many times we need to read a block, but we may not feeling that when you are using your operating system. When your operating system, you just know this is my C drive, this is my D drive. I'll just copy from here. This is my D drive. I'll just copy. I'll just paste it here. So we will be doing that. So you never feel that, but internally it is happening that way. Internally, your operating system makes sure that it will read by block by block, block by block, block by block. So each block is a 4 KB. It means to reach 1 GB, to read 1 GB data, it is making millions of requests. That is called seek. We will call a seek. What is that seek? Try to understand, guys. What is a seek? So if you observe closely how the data will store into hard disk, so in the hard disk, we know that we have something called tracks. These are all tracks. In a hard disk, we have a tracks. These are all called tracks. There will be so many tracks, okay, and you will be having something a read a write a head, okay, and it will be having sectors. This looks like a spider house, right? So these tracks are called, these are called track. These are called the lines. These lines are called sector. Your block is nothing but whatever the data stores in between this. This is a block. Small piece of data which you load into in between one sector to another sector. So that is block. This is block. So what does it mean? So if you are loading 1 GB data, it is happening, it is happening like this. It is putting your data into a hard disk, so many blocks. So when you are reading the data, each time it is reading this word, your read write ahead will be there, right? This will read the data from one sector to another sector, whatever the space it is occupying or whatever the time it is taking, that time is called seek time. Whatever it is reading, the piece of data, whatever the request is sending, that is called seek. Whatever the data it is reading, that is called block. It means in the local file system, it is the size of the 4 KB. Okay, some file system 8 KB, right? It will be, most of the time it will be in KBs. So when I want to read this data, I have to request so many times. My reader write ahead, it has to go so many times. It will be keep spinning. My reader write ahead it will be reading so many times. And if you observe, this is reading, okay, and the data has to transfer, right? If you observe, there is something called data transfer rate. So the data transfer rate is always 100 Mbps. The hard disk, the data transfer rate reading from the hard disk and putting transferring through your file system, or transferring through from your hard disk, the data transfer rate is 100 Mbps. It's always 100 Mbps only. It is not improved as of now. For each channel, each IO channel, for each core, we'll be talking cores and all, right? The reading and write transferring is 100 Mbps. It is not changed. So what I'm doing, I'm reading here. I'm reading from 4 KB from here. I'm passing through this data transfer rate. So I'm receiving here 4 KB. But this is capable of passing 100 MB, right? This is capable of passing 100 MB, but you are passing only 4 KB for each seek. It means we are not utilizing fully the data transfer rate. We are not utilizing our data transfer rate fully. So how to utilize the data transfer rate fully? So that I'm going to show you now. Okay. So this is how the local file system works. What is the problems in the local file system? Because in the local file system, or the file systems whatever you are using, it can be FAT, it can be NTFS, new technology file system, or it can be ext3, ext4. Okay, what are the file system you are using? What is the limitations with it? I'm not telling that these are disadvantages. I'm telling the limitations. So what is the limitations here? Suppose I want to make use of this fully data transfer rate. I can say it's the DR, data transfer rate. So I don't have a control. So I want to read a bigger block at a time. So 4 KB, right? No, I don't. I want to read 1 MB at a time, or I want to read 100 MB at a time. I don't have that mechanism. I don't have that control. So I want to increase my block size. I don't have a control. And also in the local file system, let's assume that I'm storing some file into some C drive or D drive. Some file here, C drive or D drive I'm loading. I want to copy multiple copies in different locations for the backup purpose. I don't have that option. So what is happening? These are the limitations with your normal file system, right? So that's why we need a special kind of file system to process the huge amount of the data. What is that special kind of file system? We're going to talk about that. That is called HDFS, Hadoop Distributed File System. So this is about the file system, guys. Now try to understand what is a distributed. We need to understand what is a distributed also here. Try to understand what is a distributed. The name itself is saying that distributed. It is given to multiple people. Distributed, it is given to multiple people. What we are doing in the distributed environment, that is called, most of the time we'll call is a distributed file system, or network file system. Okay, DFS is the concept, network file system is the implementation. Network file system is from the Microsoft. Okay, network file system is from the Microsoft. Now we'll be keep hearing from interviews also, what is the difference between the network file system and distributed file system? Why we need Hadoop distributed file system when I have a network file system? Now first try to understand what is a network file system. Here if you look at here, the name itself is telling the data is distributed. It means the data we are loading into different machines. I'm putting into 4 machines here. So this machine stores only employee type of data. This machine stores only student type of data. This machine stores only softwares, and this machine stores only project information. Let's assume that. Okay, it is like different countries, they're holding the some sales information in different countries. Now I have something called my client machine who wants to process the data, employee data you want to process. What he need to do? If you don't have a distributed file system, what he has to do? He has to log into employee through using SSH if it is a Linux environment, or he has to log into the specific environment and he has to process the employee data. He has to make a special request to come here and process it. And after finishing this, he want to, so it is like it is not parallelly, he cannot process on all the machines. First he need to process with the employee, then he can go process student, then he can go process software, then he can go process project. But I want a channel where I can access each and everything in a single place. I don't want to access each and everything independently. Every time I need to make a new request. It is like small machines are working, but I want to work as a team. This is like a independent people, so the who are not belong to team, they're just independent, but I want to work as a team. So then what I need to do? So for this kind of problems, the Microsoft come up with something called network file system. What the network file system tells you, you will keep one more layer on top of your file systems. You will keep one layer on top of your file system, connect all of them into network, ask them to start share the data. When they start sharing the data, they'll start, see, this is also a layer, this is also a virtual layer which will not be visible. Very simple. This layer also will be there in your hard disk only. Okay, so there will be a special location on hard disk that's called shared location. In the shared location, if whatever the data you are keeping, let's say I'm keeping in the shared location, that is employee data, and I'm keeping student data, I'm keeping software data, I'm keeping project data, I'm keeping data. Now I no need to log into each and every machine independently. What I will do, I will log into this layer. This is called DFS layer. Now as soon as I logged into DFS layer, this DFS layer, I am capable to see, I'm able to see employee data, I'm able to see student data, I'm able to see software data, I'm able to see each and everything. So I do feel, being a client, I feel that, oh, it looks like each and everything is stored in a single hard disk. I no need to make a multiple request to get the data. So I can go ahead and process. If I want to process employee, I can go ahead and process here. If I want to process student, I can go ahead and process this. So he can have a flexibility. He don't need to make a request every new request. So with one request only, he can read the data from all the machines, right? One second, guys. Thank you. So with one request only, I'm able to access all the data. So for him, it looks like single hard disk. This environment is called distributed file system, or this environment is called network file system. This environment is called network file system. This network file system environment is nothing but your shared drives in our companies. Shared drives. We'll be having some shared drives. Okay, each and every person, let's say my colleague is sharing some data, other colleague is sharing my data. So whoever is sharing the data, when I log into the specific location, the shared drive, I'm able to see from A, from B, from C, from D, whoever shared the data, I'm able to see. If I am authorized, I can access all the data. If I'm not authorized, whatever from whichever the mission I got authorization, I will access only that data. So when you access your shared drive in your office, do you feel that the data is coming from different machines, or you are feeling that everything is in a single location? So we will feel that like everything is in a single location. That is called distributed file system. Anyway, it's a very nice distribution file system is there. Then why should I go with a Hadoop file system? What is the reason behind it? Here also there are some limitations, guys. The limitations is underneath it also uses the local file system. Okay, here also the block size is very small. Okay, that is the one reason. Second reason is if I'm processing this data, if something goes wrong with this data, I will lose the data. If something goes wrong with this machine, I will lose the data. I don't have a backup. And when I'm loading the data into this employee machine from outside by using other application, I don't have a automatic duplicate mechanism. And also the client is accessing a single machine. The whole data is stored in a single machine. Whole employee data is stored in single machine. While I'm processing this, it will be most of the case it will be a sequential process. I don't have a distributed environment here. Actually, it is not distributed. Right, to process the employee data with multiple processes, I'm not able to do, because the whole data resides in a single processor, I mean single machine. There will be a sequential process where it will take so much of time. And what is the limitation? I don't have a duplication, automatic duplication, and it is storing in a whole data is storing and resides in a single machine. If that machine goes down, I don't have a backup. And because it is storing a single machine, it will take so much of time to process, sequential process. So these are the limitations are there with the network file system. These are the limitations are there with the network file system. Now, how to solve those limitations? By using this Hadoop distributed file system. Then Hadoop come up with the duck cutting. He introduced a new file system, which is actually he's not introduced this file system. He coded the file system. Actually it has been introduced from the Google. There is something called Google file system. Even still the Google file system is available. Inside the Google, they're using Google file system only for a large amount of the data processing and storing. So the Google file system, they given just an abstraction, an idea how to do, and he adopted that. I can say he gone through that abstraction, the duck cutting, the inventor of Hadoop, the duck cutting. The guy who gone through this, he's a freelancer. Okay, he's a freelancing software developer, and he gone through that file system, that abstraction, and he implemented his own way of, by understanding the concept, or he started writing the code and he implemented it. Then finally it's like he started with doing it, and he joined Yahoo. At the Yahoo, they formed as a team. Then they done so much of research on the same concept, and they found it interesting, and they have named it as a Hadoop distributed file system. How they have named Hadoop and all, I'll tell you very detailedly. So at this point, it's not required. So then they formed a Hadoop distributed file system. So what this Hadoop distributed file system, how it is different from, what is Hadoop distributed file system, how it is different from other file system. Okay, so do you guys have any doubt till here about the file system, about the distributed file system?
Yeah, Ravi, I have one question.
Go ahead,
So
Venkat.
here, yeah, it's as a Hadoop is that we call it as a most advanced technology for the file system.
Mm-hmm.
Apart from Hadoop, with the available traditional system, which is the best file system that you can say?
Along with the Hadoop file system, is there any other
No,
file system? Your question
no.
is like, sorry, go ahead.
Yeah, before a Hadoop file system exists, what is the best file system that we have currently in the market?
DFS is there, network file system is there.
So that network file system, that it is a concept that is driven from operating system side, right? It is not about the technology side.
Correct.
So Hadoop file system, that we call it as a operating system side or otherwise a technology side.
See, Hadoop file system will call from the operating system, technology wise as well as from the operating system perspective. It is a new technology. It is a new technology for the file system.
So when I say that, like NFS will come into picture on top of your technology that drives the operating system, right?
Correct.
So when technology, when my file system, say suppose if it is a mainframe file system, if I go ahead and store my data on mainframe, that's where the operating system NFS will come and it will place the data as it wanted.
Correct.
So in the same way, Hadoop file system, does it takes care of NFS as well as DFS, or otherwise it is independent of NFS?
Okay, it will take care of your distributed file system as well. I mean NFS as well. Here,
okay,
that,
so it is a combination of both then.
Exactly. It is the advanced NFS, I can say.
Okay. Okay, so that means that like it is not dependent on any of the operating system
No.
that drives kind of NFS, right?
No, it is not dependent at all.
Okay,
That I'm going to explain you. That I'll explain you when I explain the HDFS. You'll get the clear idea about it.
Okay, sure. Yeah, thank you.
Yeah. So any other doubts, guys? Okay. Thanks. I think no one has any doubt. Let's move for now. We have seen some problems with the distributed file system also, right? Then move to what is a Hadoop distributed file system. So Hadoop distributed file system follows same kind of architecture only, but it follows an architecture is called master slave architecture. This is also a virtual layer on top of your local file system only, guys. This is not something special. This is also a virtual layer on top of your file system only. This is also a virtual layer on top of your normal file system only. So when you install your Hadoop software, when you start the services of Hadoop services, it will create a virtual layer on top of your file system. And how it is different? Very simple. Here, I'll tell you only two, three features here, how it is different from here. In this, the difference is whatever the data you are accessing through this layer, actually the data is loading into hard disk only. We need to understand this point. Okay, anyway the data will go into hardware, that's called hard disk, right? So if you are accessing through this file system, your normal file system, if you are accessing through this file system, the block size is 4 KB. If you are accessing through HDFS, the block size is very bigger. It means your HDFS can read very big blocks. Your HDFS can read very big block. The HDFS block sizes are 64 MB or 128 MB based on the Hadoop version you are using. Okay, that is the reason. That is the difference one. The difference two is whatever the data you are storing into this layer, HDFS layer, by default it keeps 3 copies for the backup purpose. Why it is 3? Why can't it be 4? Why can't it be 2? Why can't it be 5? We will discuss that very detailedly. That is, for to understand that, we need to understand the rack awareness. We will talk in detail about this. So very simple, guys. If you are accessing your hard disk through local file system, you are going through 4 KB. And if you are accessing your hard disk through HDFS layer, we are accessing bigger blocks, because it is capable of reading a very big block. It is capable of reading very big block. It can make use of your whole data transfer rate. It means single seek, I can read MB of data instead of KB of data. So another difference is, if I don't like 64 MB, I want to reduce it, I can reduce it. I don't like 64 MB, I want to improve it, I can improve it. I mean increase it. So a developer has a flexibility where he can change the block size or a replication size. Being a developer, I have a flexibility. So how my data has to load, how I have to retrieve the data. So all the flexibility is available for this HDFS layer, where that flexibility is not there with other file system. If you don't like to read 64 MB in at a single shot, you want to read it in 128 MB at a top, go ahead and change it. It is just a configurable. It's just a configurable. To form this HDFS layer service, HDFS layer, we need to start some services. That's called HDFS services. Some people call DFS services, some people call HDFS services. We need to start those services in your system, right? So we have a flexibility, we have a control on this. We have a more control on this than your local file system. That's the difference. Those are the differences. Now look at how HDFS looks. How HDFS looks internally. I mean, what is the architecture of your HDFS? To form architecture of HDFS, we need two type of machines. We need two type of machines. One machine is master machine, master type. We'll call as a node. Guys, we'll call node. What is a node? Node is nothing but a physical machine which is installed in the network who connects to two peers, who connects to two different machines, or who connected in the network, who is started giving you taking the request and giving the response. Any machine which is there in the network who connecting multiple machines through that machine we can call as a node. Very simple terminology. Okay, so to form Hadoop cluster I need two type of machines. To form a Hadoop cluster I need two type of machines. So one is a master type machine, other one is slave type machine. One is master type machine, other one is slave type machines. The master type machine we are calling as a name node. Why we are calling as a name node I'll tell you later. Okay, why they have given the name as a name node I'll tell you. And other one is it's like a data node. And these guys are connected to each other. Here also there'll be connection. Okay, they're all connected to each other. When you see this architecture, you are realizing that in a day-to-day life, we will be seeing this type of architecture, like our manager and we. Our manager and we. A master is like a manager. He is like a manager, and he is like these machines are like we, the slaves. Okay, we're not actually slaves, no. So these are not I like. This looks like a slaves. Here, so very simple to compare that example, real-time example. Does our manager does our manager will he do any testing or development work? Let's say the new task came, one task came, so I need to develop some application, or some bug came, some bug. So is your manager assign this bug himself and he will start working, or he will assign this bug to other developers? He will assign that bug to other developers. So because he has other work to do it, that's called managing. The same way here the name node will not store a data. Very simple. It will not store any data. Your name node will not store any data. Okay, he will just manages what he will manages. So he has what are the slaves he has. The slaves will be keep telling to him, keep reporting him. How we report through pinging, through messages, through stand-up meetings, how we are reporting to our manager. The same way these machines are reporting to name node. They will be reporting to name node saying that we are alive. The duration for the reporting is here 3 seconds. But normally in our case, we are reporting in hourly, like every day once, right? But here they will report in every 3 seconds. This is called, so people will call heartbeat. This heartbeat uses the protocol called RPC, remote procedure call. It is a protocol. Okay, so why RPC? Because it's a lightweight protocol which will carry the small information. We need to know the RPC. Okay, I'll show you the RPC code as well. So what this RPC will do, it will carry the small in message to name node. Okay, saying that I am alive. So now this is architecture. Okay, like your master and we. Okay, now how the data storage will happen in these machines. How the data storage will happen in these machines. So I'm just going to clear this part because I need them. So I'm going to make use of this space. I need the space, so I'm clearing this. Now how the data, okay fine, we understand the physical machines. There is one machine called master node, there is one machine called data node. How the data will load and how it is different from other machine to load the data here. So let me take a simple example, guys. I love to explain with an example. Here let's assume that I have some data, the same like a Hadoop PDF, how we have the same way I have some PDF a PDF file or a text file or log file which is belong to Amazon. This is Amazon file and they want to put it into HDFS because it's a very big file. They want to put into HDFS. So what we will do, we'll be having something called client. Client is nothing but from where you are executing your commands, guys, nothing else. From where you are executing your commands, that is called client, nothing else. Now, as I said before, whatever the data you want to store in the file system, it will break into pieces. First it will break into pieces. That is a common, whether it's a local file system or whether it's a HDFS, that's common. Okay. Now here let me show that. Here what will happen, what are the file system, what are the data you have given. Let's assume that the data is 1 GB. Okay, I'm just taking 1 GB and my block size is 64 MB and default replication, we'll call replication factor, it is 3 copies. Okay, this is my properties, my HDFS properties, default properties. Now this file has to be break into 64 MB blocks. So how many blocks will come for 64 MB? For 1 GB? Close to 17 blocks will come. Close to 17 blocks will come. Block 1 and so on, block 17. 17 blocks will come. Correct? So what your client will do, as soon as you execute a command to load a data from your file system to other machine, this is from other machine, no? This is other machine. Amazon machine it is. Or your any other machine, your node. Some people call edge node. Okay, the edge node can be your client machine. Okay, some people call edge node. Now this data I need to put into HDFS. This is local file system, this is HDFS now. So what I will do, I will use the client. I will use the client is nothing but wherever you are executing your command, that machine is a client. Suppose if I'm using if I'm using a command in my terminal, this terminal is my client. Okay. So now as soon as you execute a command to load, that your client will divide the data into pieces in the blocks, because your client knows that what is your configurations. How my client knows? My client also should have a Hadoop software. My client also should have a Hadoop software. He knows it. So he will divide into the pieces. Then after dividing into pieces, what he will do, he will take the first piece. Even normal file system also same, guys. He will take the first piece there also. So client will take the first piece and will go to the name node saying that, hey master, I want to load Amazon file into HDFS and I need, these are my properties. This is my hard disk space and this is my replication factor. I want to store into HDFS. I need 3 machines. Why 3 machines? Because we have 3 copies. We need to put into 3 copies. So your master, what he will do, he will look into the machines. Your master will have a metadata about these machines, no? However, our manager will maintain Excel sheet about us. Same way. So he will look into that. Here it is not Excel sheet. He will be having his own metadata and he will be having his own meta files. Okay. He will look. There is something called rack awareness and block placement policy. There are 2 algorithms are there. We will talk about them. So he will look into that and he will apply that algorithms and he will choose some machines. Here I'm choosing machine 1, machine 3, machine 5. So it is not always fixed. It can take 1 2 3, it can take 2 3 4, it can take 3 4 5, so randomly. But I'm taking here, so I want to make you understand easily. That's why I have taken 1 3 5. Okay, it will choose the 1 3 5 machines and it will tell to the client saying that you go ahead and store in these machines. How it will give? These are all IP addresses. So this name node, before giving to the client, he will sort these IP addresses. Who has to go first and who has to go next? How will sort? The distance between the client, who is near to the client, that will go first, and the next nearest one, it will go first, next nearest one will go next. So that way. So your master is responded with 1 3 5. So your client will be having a buffer. Okay, here he will keep 1 3 5 IP addresses. Then he will go and connect to machine 1, because nearest machine, no? Why we need to connect nearest machine? If you connect to nearest machine, you can easily transfer the data. transfer the data. That's why he will connect to the nearest machine and he will tell to this machine, you connect to the machine 3, because he knows the which IP address has to connect, and he will tell to the machine 3rd, you connect to the machine 5. Okay, now your client will start processing, or client starts sending the data, because it is a very big block. 64 MB is not a small file, right? If you take even any small file or any file from your HDFS or your local file system, that is not, if you take any file, that is not, it may look small, but it's 64 MB means it's really very big block, very big file. Okay, so we cannot transfer 64 MB at a time in the network. So what we know that network, the packets, the whole data will be divided into 64 KB packets, and it will transfer. First it will send one packet here, the same packet will come here, copy, and the same packet will come here. So that way the data will store in this way. So I'm taking here the positive scenario, all are success scenario. I know that you guys have a doubt, what will happen if mission 1 fails, what will happen if mission 3 fails, what will happen if mission 5 fails. So I will tell you that in detail, so not to worry at this point. So let's assume that your client will tell to mission 1, you connect to mission 3, you connect to mission 5. This information, right, what are the information? This information will be maintained by your name node, guys, because your manager should know, no, when the new client came, a new work is assigned to you, your manager should know who is working on where. Here your manager will maintain the metadata information. This is called meta information. Okay, this information, the Amazon file has been divided into block 1, because he came with the first block only, block 1. The block 1 is stored in 1, 3, 5. Next your client will go with the second block, block 2, third block, block 3. Let's assume that block 2 is stored in 2, 4, 5. Block 3 is stored in 1, 2, 3, and so on. Okay, so this information, whatever the information is there, right, and so on, 17, okay, and so on, this information will call as a file to block mapping. File to block mapping. This information, whatever the information we do this will call as a block to data node mapping. Why should I maintain this metadata information? Very simple, guys. Tomorrow someone come and ask me, give me my Amazon data. So they will not come and ask your data nodes. They will go and ask your manager only, or master node only. So your master node should understand where my Amazon data is located. So that's why this metadata information will be maintained. This metadata information will be maintained. Okay. Now this is how the data stores. See here, the single file has been divided into pieces and stored into multiple machines. And also it is a distributed file system, guys. This is a distributed. If you look at here, the single file which is Amazon not is stored in the same machine. It is stored in multiple machines with the replication, with the duplication. If machine 1 goes down, I no need to worry. Still I have a copies in machine 3. If machine 3 goes down, still I have a copy in machine 5. I don't need to worry about it. So this is how the HDFS stores the data. This is how the HDFS stores the data. Okay. I think everyone is clear. Any doubts? Any doubts, friends? Oh, everyone is silent. Guys, you guys, silent means you guys didn't understand.
Yeah, Ravi, I have actually Hadoop file system that I understand here, at least till the point that you covered. So when I compare with the NFS system or whatever the file system that you're talking about, the limitation of the block, that it is only limited to 4 KB, we can't increase it by any more?
In the normal file system, no, you cannot increase by we cannot increase by programmatical or something. But while you're preparing your micro, what you call the operating system, yes, they may change it, but we cannot change it.
Okay, so that said, like what is the maximum capability of an operating system when we compare it with HDFS for the normal file system?
In the normal file system, I really don't know what is the capacity, how much they can increase, but that will come along with your operating system. Who designs your operating system, they can decide it, what will be my block size. I think I have seen some blocks here that it can store 128 KB or something. So it'll be that much. That is maximum,
Okay.
128 KB.
But not up to MBs or anything
No,
like
no,
HDFS.
no, no.
Is far distance is there then
Correct.
within these two.
Correct.
Okay.
Yeah, someone was asking some doubt. Because I'm not able to hear, guys. I think someone is talking, but I'm not able to hear. Fine. So let me consider no one has a doubt. So let me take you through the process, how it is different. Now we have seen yesterday some limitations, no? The price, cost, time, all those things, right? Now I want to overcome them. So how will we overcome? Let me show you here. Now I'm coming to MapReduce part. Okay, the MapReduce also follows the same architecture, master slave architecture only. We will see very detail about the MapReduce when we are talking about later. Okay, now I want to process this Amazon file. I want to understand how many sales, how many new registrations, how many people purchased books, how many people purchased mobiles, that kind of aggregations analytics I want to do. What I will do, I will write some code in Java or whatever the language I'm comfortable, and I will, which are the language not comfortable, which are the language your Hadoop supports. Okay, so I will write up the code, the business logic, and I will submit a job. As soon as I submit a job, the client will go to, there is something called job tracker, guys. I'm not bringing those terminology here because we already uh, uh, filled with so many new jargons. There is something called job tracker, there is something called task tracker. So not to worry about these things, we will discuss later. The same thing is some people are calling now in the Hadoop 2 resource manager, node manager. So I don't want to bring a very new jargons here to, I don't want to make you afraid. Okay, here as soon as you submit a job, it will go to a master, and your master knows the file has been divided into these many blocks. Okay, block 1 is there in this machine, you go ahead and process block 1 in this machine. The block 2 you go ahead and process in this machine. Block 3 you go ahead and process in this machine. So the unique blocks will be start processing. The unique blocks will be start processing, and once they process the data, they will collect the data. They will collect the final result. That is called reduce phase. Initial phase is called map, and the final phase is called reducer. We will talk very detailedly that in the when we are talking about map reduce. Here, if you see, it is processing parallelly the whole file, right? The 17 blocks are there. Let's assume that I have 17 machines. Your whole file is processing 17 independent processes, not the threads, guys. Not the thread. I'm not telling it's a thread. It is a process. It is a specific JVM, right? So it is processing independently. So I have, let me go back to limitations. So I have a parallel process. Let me strike out what are the things I have here. I have a parallel processing. My data is distributed. My data is, sorry, fourth one. My data is distributed, properly distributed. I have a parallel process. I have a duplicate. By default, the duplication is there. Okay. And coming to data locality. So coming to data locality, third point, it's very much important, guys. We need to understand data locality more. So wherever you store the data, you are processing there only. You have stored your block 1 in the mission 1, mission 3, mission 5. You are processing that mission only. You are not copying that block to some other processing location or processing area. So wherever you have stored the data, you are processing that location only. This is called data localization. In Hadoop, we have a data localization. So because if you have a data localization, it will take less time to complete or to process the data. Yes, I have a data localization. My data is loaded into mission 1, mission 2, mission 3. I'm processing in their mission 1, mission 2, mission 3 only. I'm not moving my data to other place. I'm not moving my data to other processing engine or somewhere. And coming to automatic fault tolerant, if you see here, you have already loaded into 3 copies. While I'm processing, mission 1 is failed. You don't worry. The system, my process, my Hadoop is smart enough. You don't worry. There are 2 more copies in other machines. I will launch a job there. You no need to worry. The job will not fail. Because of one machine fail, your job will not fail. The duplicated data will be available in other machine. You are smartly to launch another machine. Okay. So you have fault tolerant as well. you have fault tolerant as well, right? And coming to cost and time, so because I could have explained this what is the cost and time before only, so now but I want to make you a little comfortable with this. So coming to the cost, your Hadoop, as I said before, it is open source, you no need to pay to anyone. But you may say that, Ravi, you're copying 1 GB data into 3 GB, so what about hardware? Yes, I'm spending something in hardware, but hardware is so cheaper than your data. So cheaper than data. That's why I used to take an example, mobile. If we lose a mobile, we'll not worry we are losing a mobile until unless it's a very high-end phone or something. Until unless you have invested, thousands of money in it, like 50,000, 70,000, 80,000 kind of thing. So what we will do, most of the time we will be worrying that I have lost the data, contacts and photos and images, whatever it is. And also Hadoop required commodity hardware. You don't need dedicated hardware like a traditional systems. Even if you go and take your laptop which has a 16 GB or 32 GB or 64 GB RAM and 1 TB hard disk and 6 core 4 core machine, you can go ahead and connect your machine, you can go ahead and run it, no problem at all. You don't need a dedicated machine. So cost is very less comparatively a traditional systems. And coming to time, yes, I have a parallel process, I have a data locality, I have a fault tolerant, it will consume a less time, no doubt in at all, no doubt in that at all, right? And also guys, your Hadoop is coming to this. Hadoop is, I can say, heterogeneous cluster. So Hadoop is heterogeneous. What is heterogeneous? So let's assume that my mission 1 is Linux, which is Red Hat. Mission 2 is Ubuntu. Mission 3 is CentOS. Mission 4 is Mac. Mission 5 is Windows. Mission 6 is something. I no need to worry what operating system I'm using in my machines. Any type of machine, any type of hardware, you can go ahead and connect to your Hadoop cluster. You can go ahead and start working. So Hadoop is very simple. Connecting small machines. The concept is very simple, guys. Connecting small machines which cannot able to process a huge data independently, connect each other and make it work as a gained machine. Connecting small machines and working together and working as a gained machine, that's called teamwork, right? We'll call it teamwork. Who is not able to finish the whole project is a single person, so what we will do, we will divide the work and we'll work as a team. So this whole cluster will work as a single computer, guys. Single supercomputer, I can say single supercomputer. That's why it is I can say very we're connecting very cheap machines or small machines. We are very much happy to connect the small machines and work as a very big machine. So that's why Hadoop is more popular, which is very less in the cost. Okay, so this is about Hadoop, and in the next class, so tomorrow I'll be showing you Spark demo as well. In the next class we will be discussing something called something related to Spark as well. Then from Monday we'll be continuing the classes. From Monday we will be continuing the classes. If you guys have any doubts, please go ahead and ask me now, and I'll answer more, no, maximum whatever if and whatever questions I know, I'll answer them. Raj is asking one question: is there any way to correct the corrupted data even though there is two more copies? What if the two copies are damaged? Okay, Raj, to answer your question, if I have let me put in this way. His question is that the block 1 is 3 copies, copy 1, copy 2, copy 3. What his question is that if my two machines are corrupted, the block is corrupted, is there any mechanism uh, we can correct it or recover it? Let me see the question one more time. Okay, correct it. So there is no way to the corrupted blocks, there is no way to corrupted data can be recovered. What we can do, we can remove these corrupted blocks. Whenever we have a original copy, that copy we can replace. Your master can do that. He can take a copy from this, he can load into other machines. Understand, Raj? Okay, so we will not be knowing that how we will corrupt it. No, you have to use Hadoop administration command, something called report. So when you say report, it will show you that, and one is the report and the other one is FSCK, normal file check. As soon as you execute this command, this command, it will show you the what are the corrupted. So what you can do, you can use FSCK and hyphen delete. What it will do, it will only delete the corrupted blocks. It will not delete the normal blocks. It will delete only the corrupted blocks, and it will shows that it's supposed to be 3 copies. It is there only one copy. It will shows that it is under copy. So under copy we will talk tomorrow. So what is under replication? So the question is, if anything is corrupted, what will happen? So corrupted blocks can be deleted. We cannot recover them. Okay. Any other doubts, guys? Yes, by default.
Veera, I have one doubt.
Yeah, by default replication factor is 3. Yeah, go ahead. Yeah.
Yeah. This suppose if we have only 3 nodes, then how the replication happens?
3 nodes means you will copy one copy in one machine.
In one machine, right?
Yep, yep.
So if this is a single rack, right? When you have 2 racks, the replication will be different.
Very good. When you have, when you're going for the Hadoop cluster, we should go with the multiple racks. We cannot go with a single rack.
Okay, it is a must or it is a choice?
It is a must.
Okay.
It's not a choice.
So if we have, each Hadoop setups will have minimum 3 racks, you meant to say?
Minimum 2 racks. Not 3, minimum 2 racks.
Okay, but the example you gave is in single rack and
no. It is not. It is not a single rack. The example I have. It's an architecture. It's a high-level architecture which I have shown you. That is, it can be multiple racks. It can be a single rack.
Okay, fine.
And Bira, this is Bikash here. One doubt I have. Yeah, so suppose this replication factor is 3, okay? So the name node will decide this data node based upon this some algorithm, right? Some shortest path algorithm must be using.
Exactly. That is called replacement policy and rack awareness.
Okay, so basically suppose first block is going to data node 1, okay? It finds that data node 1 is the shortest path, so I will put my first block in data node 1. Then the copy of that first block, how it will decide? It will decide the algorithm will sit on the data node or it will sit on the name node only to find what is the shortest path.
See, the algorithm is already sit in the name node. I mean, it is part of your framework. Okay, the algorithm is already applied and it is given the missions. It is not like every time it will apply the algorithm. While identifying the mission itself, it will be identified the missions.
Okay. So name node has got this.
Exactly.
Yeah.
So while choosing the mission itself, it will apply the algorithm and it will find the mission. Mission 1 is nearest to the client. Mission 3 is next to nearest. Mission 5 is next nearest. And that it will give only IP addresses. And your client will connect to the missions. As soon as this data node stores their data, they will report to the name node saying that I'm success, like that. So you once your client receives the response from the client, there won't be any communication again with the client and name node.
Okay. And one more thing, Veera, suppose this complete rack goes, okay, so the rack, so it has to be, the copy has to go to another rack, right?
Yes. So copy is not go actually. By default, it will be in the multiple rack. That's why, as I said before, we should maintain minimum 2 racks. Even though complete rack goes down, that we will discuss in the next class. Okay, even complete rack goes down, what will happen is already the copies are already there in the other rack. You don't need to worry about it. By default, other rack has the data.
Okay. Yeah.
Any other doubts? Okay, so here our friend is asking one doubt. If it is the block size can be changeable, what is the maximum limit? Okay, the question is, let me read it for you. By default replication factor is 3, and what is the maximum limit? Okay, sorry Karthik, I understand it's a block size. Replication factor is, you can change, minimum is 1, maximum is 512 by default. You can also change it. So whatever the replication factor you are changing, whatever the replication factor you're changing, you should keep in mind that we have those many machines. You are keeping your replication factor is 1000. If you don't have 1000 machines, I mean at 1000, there is no point to have 1000 as a replication factor. You should have those many those many machines in to keep those many blocks. There is no limit. There is no limit at all for that. So based on the resources availability in your machine, in your cluster, you can go with that. Okay, so that's it, guys. Any other questions?
Yeah, Ravi, this is Ashwani. We are trying to replicate in 3 times, right? What about the performance of the system?
So there is no any performance hit here. It is like you are storing while you're loading the data. Anyway, that will take time. Loading the data anyway, it will take time. That
Right.
there is no problem.
Right. It will take time, but we are replicating it in 3 times. But it consumes time, right? If it is a 3 times or 5 times.
No, it'll why it'll 5 times. It will be 3 times only. No.
Right. Right. If we are doing it in 3 times, it consumes some time, right?
Correct. That's all. We're happy with that. You know, we need a data backup. So why we are loading into 3 places, 4 places? For my data is more important me. So suppose the Amazon data last 6 months data I'm loading. If I lost my 6 months data, I may not able to get the same data again. The data is more important. So while loading the data into the cluster, it takes time. I'm very much happy with that. No problem at all. But I understand it's taking time to copy 3 places. If you think that your data is not that much important, you can store in 2 copies only. You can store 1 copy only. You can do that.
Okay.
And also it's one of the interview question. I have one of my student asked me the same question. I have a 1 TB data while loading Howat. Yes, it is a sequential process only. While loading the data, it is a sequential process only. It will take so much of time if you are not using any other tools, explicit tools. There are some external tools. If you use those tools, if you didn't use those tools, your normal load the data into HDFS is always sequential only. It will go block by block, block by block. It will take time.
Okay. Is there any mechanism to retrieve the data from file system?
Which file system you are talking about? The HDFS?
Yeah, right.
Yes, we can retrieve we can load it back, you can take it back. That's called, we have a commands. Put command and get command. And copy
same
from
like Unix.
Yes, we can copy from local, copy to local, and you have something called move from local, move to local. There are some commands, you can do that. And Karthik, if I have a sufficient missions where we need to change the replication factor value. Very good question, Karthik. We will be having some configuration files. I'll be showing the configuration files. In the configuration files, you will be changing the value. You'll be changing the value. Okay. Okay. So. So we cannot control, Raj, we cannot control the data no storage. So that will be taken care by your framework, I can say, your name node. So where it has to store, it will be decided by the name node. If you want to write, you can write your customized algorithm and you can give to the framework. There is something where you need to change the configuration. You need to give that algorithm. You need to install that algorithm in your framework. Yes, you can do that. But you have to write your algorithm. If without writing your algorithm, you cannot customize. You cannot control. Okay, so thank you guys. Thanks for your time. Have a great day. So I'm closing the session.
Thanks, Ravi.
Thank you guys.
Thanks, Ravi.